Alright, so welcome back to everyone. A very warm welcome to all of you, all the NEET aspirants, all the future doctors. And I am Dr. Umashikar Tripathi again, and I am here to solve some previous year questions from the topic of error analysis. So, guys, previously we have done the previous year questions from the topics of principle of dimensional homogeneity, dimensions, forming the formula between physical quantities. And in this session, we are going to solve some previous year problems and very important problems of the error analysis. Okay, okay. So, guys, again, I am Umashankar Tripathi, your physics educator, and here we go with some beautiful problems which is triggering your concepts. They will solidify your concept and will make you more comfortable in the topic of error analysis. So here we go with the first question of the day. So please solve this question before I do it. Those who are watching this video, please pause your video, and I hope that you have seen the session of error analysis and how we can see the errors, how we can take care of the propagation of the errors. So we have spoken about it in quite a depth in the previous sessions of error analysis, and in this session we'll be solving some more questions so that we understand this topic in an even better way. Okay. So what it says, so the period of oscillation of a simple pendulum is t is equal to 2 pi root L by G. Okay. So they have mentioned you formula here, but they may not mention this formula to you. The measured value of L is 20 centimeter known to 1 mm accuracy. Okay, known to 1 mm accuracy, and the time for 100 oscillation of the pendulum is found to be 90 seconds using wristwatch of 1 second resolution. Okay, the accuracy in the determination of the G is. Okay, okay, so now how we are going to do that? So first of all, we know T is equal to 2 pi root over L by G. Okay, now we have to find error in G. Now when we have to find the error in G, let me take it to the other side. So we can write, so let me square this whole relation. So it will become T square 4 pi square L by G. So G will become 4 pi square L upon T square. 4 pi square L upon T square. Now there is no error in this 4 pi square. Okay, there is no error in this 4 pi square. So when there is no error in this 4 pi square, we can simply ignore it, and we can do by this thing, right? We can do by this L and T square. So from here I can write, see, if I use the principle of the errors, so we can write delta G by G is equal to delta L by L plus 2 times delta T by T. Okay. Okay. So we have to find in percentage, right? Okay. In percentage we have to find. So what we can do, we can multiply 100 to this whole equation to every term. So this is going to be delta L by L into 100 plus 2 times delta T by T into 100. Okay. Now this delta G by G into 100, what it is going to be? So this is the percentage error in the gravity. So this is delta G by G into 100 is equal to delta L by L. Now please understand this. Let's sort out this. So delta L is what? Delta L is 1 mm. So we can write it as 0.1 centimeter, because obviously in 1 mm we have how much centimeters? So we have 1 by 10 of centimeters, right? We have 1 by 10 of centimeters. So we know that. So delta L is going to be 0.1 centimeter, L is 20 centimeter, and the time for 100 oscillations. So if you see the previous video, so what is delta T and what is T? So it is the error in the measurement. It is the error in the measurement of the time for one oscillation. Okay. Okay, so it is not given to us, although we can find it like this, delta T by N, no worries. And what is this T? So this is T upon N. Okay. Okay, what is the time taken in so we did it comprehensively in the last session. So if the time taken in 100 oscillation is 90, so obviously the time taken in one oscillation is t upon, that is 90 upon number of oscillation, that is 100. Okay, and we also know very well that delta t upon t is equal to capital delta T upon T. This is what something I have proved in the last section. No? Okay. From here itself, you can write this, no, with the concept of the differentiation with the formula of this, you know, with the formula of this error. Okay. So right away I can write it here. So instead of delta t by t, I can use a small delta t upon a small t. So delta L by L is what? It is 0.1 upon 20 into 100, right? Plus 2 into delta t by t. So delta t is what? Delta t is 1 second resolution. See, resolution, when they say resolution, when they say least count, they all are the same thing and it represents the error. But remember, when it says 1 second resolution, so it is 1 second resolution. That means it is the error in the measurement of this 90 seconds. Don't misunderstood it with the capital delta T. That is the error in the measurement of one time period. So it is not that. Okay, it is not that. So we are having, let's write delta small t upon t into 100. Okay. Okay, so from here what we can do, we can write delta g by g into 100. That is the percentage error in the g. So from here I can write, so it will become zero point 0.1 into 100 by 20. I'll just put the values first, plus 2 into 1 by 90 into 100. Okay, so from here what we are getting, what, don't divide 100 to it, no, because we wanted to have the answer in the percentage. So this is obviously becoming zero point 0.5. Okay, and this is going to be 10 by 9, that is 0.9, so it is going to be 2.22. So from here this is 0.5 and this is 2.22. So we are ultimately getting somewhere near 2.7%. So what is the nearest option? Nearest option is 3%. So the answer is 3%, right? Okay, you have rounded it off to the next digit. So it is going to be 2.7%. Okay, if you wanted the exact answer, but if you rounding it off, it is going to become 3%. I hope it is fine to everyone. Now let us move to the next question. Okay, let us move to the next question. So the next question is a bit lengthy and tricky. Let's see if we can do it. Actually, it is not a question of need. It is a question of JEE advance. Sir, why you are giving us the question of JEE advance? Because see, what I believe that when you are reading a topic, when you are reading a chapter, it is always advisable that you do at least some of the trickiest question, because see, one tricky question is equivalent to 20 simpler questions, and each of the question which I am choosing, I am trying to give you some concept out of it. Okay, now let's try. This is the question. Ah, okay, so we have, okay, this is the question, and we have in G, so delta G by G for students, and then so I'll give you some options. So option A is the E1 is 0. Okay. Option B says E1 is minimum. You have to choose in them. Option C says the E1 is equal to E2. E1 is equal to E2, and option D says E2 is maximum. E2 is maximum. So these are the options to this question. Okay, these are the options to this question. Okay. Okay, sir, we cannot read this question. Because of my video. Okay, I'll just shut down my video for once. Okay, you can take the screenshot here. You can take the screenshot, and sir, also we are unable to read this too. So I'll just do one thing. I'll just do one thing. I'll just write it here. Okay, E2 is max. Okay, and D is E1 is equal to E2, right? Okay, so now I think you can read this question. Okay, perfectly. Now please try this question. I'm very sure that if we try to do, we can do it. And I'll paste this table over here so that you can see me as well. I'll just open my video too, and you can refer the table from here. Okay, okay. I don't want you to not see me, right? Okay. Now, in this question, how we can attempt this question? How we can attempt this question? So it says, is student 1, 2, 3 perform? So there are three different students. Okay. Is student 1, 2, 3 perform an experiment for measuring the acceleration due to gravity using a simple pendulum? So this is the same experiment. They use different lengths of the pendulum and record time for different number of oscillations. Okay. The observations are shown in the form of table. So this is the table in which these observations are shown. Okay, we'll come back to this. Let's understand the question first. Now, least count for length is 0.1 centimeter. Least count for time is zero point 0.1 second. Least count is the maximum possible error. I hope you remember that. Okay, this is what we have learned now. Least count is the maximum possible error of measurement. Okay, okay. So in the measurement of length, the maximum possible error is of zero point 0.1 centimeter, and in the measurement of time, the maximum possible error is of 0.1 second. If E1, E2, and E3 are the percentage errors in G, that is delta G by G into 100 for student 1, 2, 3 respectively, then which of the following holds true? Okay. Okay, now let's understand this. Now let's understand the question. So we have to do for, let's start with student 1. So let's try to understand this question. So there are three different students. Okay. We are naming them here as 1, 2, and 3, and they conducted this experiment that you also might have conducted in your 11th physics, in your 11th standard. Okay, so here they try to measure the acceleration due to gravity. They try to measure the acceleration due to gravity. They try to measure the acceleration due to gravity through the pendulum experiment. Okay. Now, in the first case, so we know we have the formula. We just had the formula, the same formula. T is equal to root 2 pi. So can I directly use delta G by G into 100 is equal to delta L by L into 100 plus 2 times delta T by T. Okay, delta capital T by T or small t by T, they both do the same, into 100. Can we write like that? Can we write like that? Yes, sir, you can definitely write like that. Okay. Now please understand this. So delta G by G into 100. Now what is the maximum possible error? So it is 0.1 because the least count is 0.1 of the length. And since no other data is mentioned, we are assuming that each of the student has used the same scales. Okay. Okay, which has the same least count. Okay, so now we can write 0.1. Please observe. So 0.1 upon what is the length for the first case. So he has measured it as 64 into 100. Okay, plus 2 times delta t. Now please understand this. So now he is using equipment of least count, the equipment for time, the instrument for time with the least count of 0.1 second. So this least count is the error, maximum error in the measurement of this n oscillation. So how many oscillations he took? He take 8 oscillations, and this is the time period. So you don't have to use this. Okay, you don't have to use this. Why? Why, sir? Otherwise, you have to first get delta t, capital delta t. So why too unnecessary? Increase the calculation. So when we know delta t by t is equal to small delta t by t. So this is given to confuse you, basically. This is given just to confuse you so that you may think that, okay, sir, capital T is given, so we must first calculate delta t. So you can do this also. You know delta t, capital delta t is a small delta t by n, that is by 8. Okay, that way also you are going to get the same answer. Okay, but why unnecessary increase the calculation in the question? We ultimately have to reach to the right option of the question, right? So now delta t is 0.1 because the error in the measurement of this time of 128 seconds, this is this much. So this is going to be 128 into 100. Okay. So one way we could calculate it, but let it be like this. Let it be like this for time being. Let's go for second. Okay. So in the examination, we have to save some time. Okay. And you might be feeling, sir, in the NEET, we are doing the question of JEE Advanced. Okay. Okay. So don't worry about it when you are good at concepts. So question is tough. It is not that tough. That doesn't matter mostly. And this question will improve your concept. Now, in the second case, the delta L is 0.1, L is 64 again, and this is going to be multiplied with 100 plus 2 times delta T. So delta T is again 0.1. Okay, and now in this case, the T is 64. The T is 64 into 100. T is 64 into 100. So let it be like this for time being. Okay, so this is the error in the measurement of the second student. Now in the third one, if I go for the third one, so for third one, I can write delta G by G into 100. Again, it is equal to delta L by L into 100 plus 2 times delta T by T into 100. So for him, again, the delta L is 0.1. The L is 20 into 100. The L is 20 into 100 plus 2 times 0.1 upon 36. 0.1 upon 36 into 100. 0.1 upon 36 into 100. Right. Now from here, so one way you can calculate it and get it a good value. But one thing is very clear. One thing is very clear. Now please observe, this is 0.1 by 64 into 100. So see, we have to reach the right option now quickly. So either way you can do, you can first make this calculation, make this calculation, make this calculation, or you just can see by comparison. See, clearly I can see that E2 is greater than E1. E2 is greater than E1. How so, sir? Why so? Because see, this first part of E1 and E2, that is 0.1 by 64 into 100, 0.1 by 64 into 100, it is same. It is same in both the error in measurement by student 1 and by student 2. Now, in the second part, it is 0.1 by 128, it is zero point 0.1 by 64. So, definitely E2 is greater than E1. Now, let's see. Let's see. So, E2 is greater than E1. So, first of all, this is gone, this is gone. These two is gone. Okay. Okay. Now, E1 is minimum or not? For that, we have to see E3. Now, E3. Now, see this part. Now, this part. So, definitely this part is greater than this part. And this part is also greater than this part. Don't you feel so? See, this is denominator 64. Or see, if you find this difficult, you can go for the calculation. But if you use a little bit of mathematics, okay, so here it is 0.1 by 64, it is 0.1 by 20. So this part is greater than obviously from this part. Now similarly, here it is 0.1 by 64 and here it is 0.1 by 36. So definitely this part is also greater than this part. So clearly E3, the error in the third one is the greatest. Sorry, okay, it is the greatest, no? Because this part is greater, this part is also greater, so it is greater than this one. So what could be the right answer? So E2 is max, no, E3 is max, but E1 is minimum. Okay, so this is going to be the second option. So here they have given you the question in the form of the table. Okay, and sometimes I have seen students that, sir, whenever table is there, we feel that something very difficult comes up, and now we think that whether we are going to be able to solve it or not. Okay, so you don't have to feel that way. Okay, you'll have to always and always try to use whatever you have learned. You must try to use the concept that you have learned, and afterwards you will definitely be able to get the answer. Now let's try this question. Let's do this one. Let's try this question. So it says, what does this question say? So it says a student uses a simple pendulum. So again, I'm telling you guys, requesting you guys in a way that always do the question before I attempt it in the session. Okay, you may pause the video for time being and then you can find the correct answer. So this is a MSQ question, multi-select question. So it may have multiple correct options. Okay, okay, now let's see. Now it says a student uses a simple pendulum. Okay, a student uses a simple pendulum of exactly 1 meter length to determine g, the acceleration due to gravity. He uses a stopwatch with the least count of 1 second for this and records 40 seconds for 20 oscillations. Okay, very well. For this observation, which of the following statement is true? The error delta t in measuring time, the time period is 0.02 seconds. Now let's see if this statement is correct or not. Let's see if this statement is correct or not. Okay. Okay. So for that, so sir, that in the previous question, sir, you might be thinking, sir, when always delta t and delta t by t are the same, we are why we are learning this formula. So now see, this is also getting used. Now, simple logic. So let's check with the first option. Error delta t in measuring t, the time period is 0.02 seconds. Now please read this. So he uses a stopwatch with the least count of 1 second. So that means that to record 40 seconds, the error in the measurement is 1 second. Okay. Okay, so let's use this formula. So delta t, capital delta t is the error in the measurement of one oscillation. That is one time period. One time period. Capital T refers to the time period, and time period is the time taken to complete one oscillation. Okay. Now to complete one oscillation, what is the error? So this 1 second least count, that is 1 second of error, is in the measurement of 40 oscillations. So this is going to be how much? It is going to be 0.05, right? 0.05 second, right? Okay. Okay, so 0.05 seconds. So this is the wrong option. Okay. Okay. The error in measuring t, the time period is 1 second. This is also wrong because this is 0.05 second. Okay, this is 5.05 second. Now let's see this. So percentage error in the determination of G is 5% and 2.5%. So obviously in option C and D only one could be correct. So let's use the formula. So from where this formula comes up? So in the last question, in the last question, we have been using the same formula. So we can use it here. Delta L by L into 100 plus 2 times delta T by T into 100. So from here, what we are getting? So delta L. Now please read the question. So it says a student uses a simple pendulum of exactly 1 meter length. Now what do we mean by exactly 1 meter? How will you understand this language? Exactly 1 meter. So sir, obviously when it is written exactly 1 meter, it simply means that there is no error in the measurement of length. So this is going to be 0. Now this is 2 and 1 second is the 1 second is the error in measuring 40 seconds. So we can write 1 by 40 into 100. So obviously this is going to become delta G by G into 100. So this is going to become, so it is 0.05 into 100. So this is 5%. This is 5%. So basically, what is the error comes up? What is the error comes up in determination of G? So the error is how much? So the error is 5%. The error is the 5%. Okay. Okay. Now let's try one more question. Okay. Again, a little bit question, because see, in when we are doing with the error thing, okay, you have to have everything clarity, everything shall be clear in your mind, how to use the formula, where to use which formula and whatnot. Okay. Okay, so let's see one more question here. Let us see one more question here. Now let's observe. So it says in an experiment So first again, before I read this question, before I solve this question, I request each of you to go ahead of me, pause this video, please solve it by your own. Please use the formulas that we have learned. Please use the concept that we have understood and then solve this question. Okay, okay. Again, a little bit lengthy question, but it seems that we can solve it. We have learned all the very concept of this question. Okay, we have learned all the concepts from this question. So basically we can try to do it. Okay, let's do it. So it says in an experiment to determine the acceleration due to gravity g, the formula used for time period of a periodic motion is t is equal to 2 pi root over 7 r minus r by 5g. The values of r and r are measured to be 60 plus minus 1 mm and 10 plus minus 1 mm respectively. In 5 successive measurements, the time period is found to be 0.52 second, 0.56 second, 0.5 second, 7 second, 0.54 second, and 0.59 second. The least count of the watch used for the measurement of the time period is 0.01 second. Which of the following statement is an R true? Okay, it's an R true. Okay, okay. Now please understand this. Very, very good question. Now please understand this. First of all, we have to see the error in the measurement of R. Now we have this formula. First, let me write the formula. So T is equal to 2 pi root over 7, okay, capital R minus R, capital R minus R upon 5G. Okay, very well, no problem at all. Okay, okay, now please understand this. Let's see the first part of this question. The values of capital R and R are measured to be 60 plus minus 1 mm and 10 plus minus 1 mm. Okay, okay, now please understand this. So in the first part, it is asking us the error in the measurement of R is 10%. The error in the measurement of R is 10%. So let's see that. Let's see that. So for R, so what is delta R here? So see, delta R is 1 mm. Okay, it is 1 mm. So delta R is 1 mm. So delta R by R is going to be 1 upon, it is going to be 1 upon the true value, that is 10, and it is 100 multiplied with 100. Okay, so I'll write it here because you are asked in percentage. So it is 10%. That means the first part is correct. Okay, very good. Okay, now the error in the measurement of T is 3.57%. So for that, sir, we need to get delta T by T into 100. Okay, this is what we have asked in the second part. This is what we have to examine basically in the to check the second option of this question. Okay, the error in the measurement of T is 3.57% or not. This is something you have to check. Now please understand this. Sir, we have this delta T. Sir, where is this delta T? Sir, delta T is delta T is 0.01 second. Okay, okay. Because see, the least count of the watch used for measurement of time is 0.01 second. Okay, sir, is it capital delta T or is it a small delta T? The question is, okay. Previously, in all the questions we have been using a small delta T, but here it is capital delta T. Sir, how come? So it is clearly written now in 5 successive measurements the time period is found to be. So time period, they are clearly mentioning the time period. So basically in this experiment, we are measuring the time period. So whatever we are measuring, the least count is the maximum error in that measurement. Okay, okay. So basically it is capital delta T. Now what is this T? So T is the true value or the actual value or the mean value. Okay. So if you remember when we started the error analysis, so there was hardly any question in which all these concepts are involved. So when we were talking about the true value or actual value, so what we have learned, no matter how hard we try, we have learned this, no matter how hard we try, we cannot find the true value in a measurement. Now, what was the way to come down to the nearest to the true value, which we can assume to be the true value? So for that, we learned that we can take multiple measurements like what we are doing here. Okay, what we are doing here, we are taking up the multiple measurements. Like we have taken 5 successive measurements of 0.52, 0.56, 0.57, 0.54, and 0.59. So all these measurements that we are taking here, okay, okay, so these are multiple measurements, and to get nearest to the true value, we can take the average of it. So let's take the average. Let's take the average. So we have 0.52 plus 0.56 plus 0.57 plus 0.54 plus 0.59 divided by 5. Okay, divided by 5 seconds. Okay, now from here, what is the t we are getting? So if we calculate it, we are getting 0.565 seconds. Okay, we are getting 556 seconds. 556 seconds. You can have it cross check. Okay, I already have calculated it, so that is why I am telling you this is 0.556 seconds. Now is it that what we are going to use? So no sir, we are not going to use this. We are going to use 0.56 seconds. Sir, why so? Why so? Because see, whenever significant figures are added in errors, you always have to be careful about the significant figures. So whenever the significant figures are added, okay, you have to get the final answer having the same number of decimal places as in the value with the least decimal place. So how many decimal places are there? 2 decimal places. So you have to reduce your answer to 2 decimal places. So this is going to be 0.56 seconds. Now what is going to be delta t by t into 100? So delta t is 0.01 second, and this t is 0.56, and this is into 100. So now from here, what are we getting? Now from here, what are we getting? Okay, okay, okay. So no. There is one mistake here. There is one mistake here. So what is the mistake here? So see, there is something missed. Okay. So the least count of the watch used for the measurement of time period is is 0.01. Is 0.01. Okay, okay, so you will have to, what is this delta t? So least count of watch used for measurement of the time. So now see, this is how mistakes happen sometimes. So this is wrong, no, this is not correct. Why this is not correct? Because when we have the true value, guys, when we have, see, this is how mistake happen. So see, delta t, this is wrong. Okay, why it is wrong, guys? Why it is wrong? So this is wrong because see, this is wrong because see, what is the error? This is the error in the measurement of this average time. See, this was this point I even also missed. Okay, just now it came to my mind. Okay, this is how the things get missed, because see, this is the least count of the watch used for measurement of time. The each of this measurement, this was the error. But what is the mean error? Because when we are using this delta t, this delta t is the mean error, right? So we have to get the delta t also. Now for delta t, we have to get what? First of all, now see, this is the least count, so it is the error in each of this measurement. Okay, okay. Now each of the measurement have some error. Okay, now what is the cumulative error? So delta t1 is going to be t minus t1. T is 0.56 second. Okay, so 0.56 minus what is the first measurement? It is 0.52. So 0.56 minus 0.52, it is going to be 0.04, right? Now similarly, delta t2, what is going to be delta t2? It is going to be t minus t2, because you have to get the average error, na? Mean error. When you are writing the mean value, you have to write the mean error. So this delta t is just to trap you. Okay, it has no use in this question. The least count is 0.01. It basically have no use in this question, right? See, this is how they trick you. So now this is 0.56. Wonderful question it is, no? So T2 is 0.56. So this is going to be 0. Okay. Now delta T3, it is going to be T minus T3. So it is 0.56 minus, so T3 is what? The third measurement is 0.57. So this is going to be equal to minus 0.01. Then delta T4, it is going to be T minus T4. So this is going to be 0.56 minus what is the measurement, fourth measurement? It is 0.54. So you are going to get 0.02, and I'm writing it here. What is the error in the fifth measurement? It is t minus t5. Okay, so this is going to be 0.56, and what is the fifth measurement? The fifth measurement is 0.59. So this is going to be equal to minus of 0.03 second, minus of 0.03 second. I hope it is fine to everyone. Okay, so we were missing something, now we have grabbed that. Okay, so why it was like that? So least count. Okay, least count. So this is not the average error. No, least count refers to that each of this measurement have some error. What is the mean error? So when you have the mean value, okay, you can have the error in each of this measurement. In each of this measurement. So don't get trapped, guys. See, when your concepts are clear, even if you are making some mistake, then something will strike you. Like how it strikes to me. Okay, how it strikes to me. Like this 0.01 is the least count. But when we have all the measurements and when we have the mean value, so we can get the error in each of it. Okay, each of it. So now what we can do, so we can get the average error now. So delta t is what? Mod of delta t1 plus mod of delta t2 plus mod of delta t3 plus mod of delta t4 plus mod of delta t5 upon 5. Now this way, when I put all the values, so we have 0.04, we have 0, then we have 0.01. So it was minus 0.01, but we have taken the mod, na? Absolute error, the concept of absolute error. So such questions are rarely asked, but if you are being able to do these kind of difficult questions, then that means that you have understood the topic very well. So this is going to be 0.02. So what is delta t? 0.02. Now we can get the error in the measurement of time, delta t by t into 100. So this is going to be 0.02 upon, what is this t? T was 0.56 into 100, and this is going to be equal to 3.57 percentage. So that means the second option is correct. The second option is correct only. So third cannot be correct. Now they are also asking that what is the error in determining the value of g. Okay, so now for g we can, so when we have the errors in everything, we can get that. Now please see, there is some trick to that also. Now t is equal to 2 pi. So this is not the usual equation we have been dealing with. 7r minus r, 7r minus r upon 5 of g. So what we do, we first square this. Let's square it. So it will become t square 4 pi square, and this is going to become 7 by 5. So these constant numbers we have nothing to do, and this is going to be r minus r by g. So g is going to become r minus r upon t square. Okay, this is going to proportional to. I don't have anything to do with this 4 pi square 7 by 5. Okay, okay. So what we can do here? What can we do here? So we can now write delta g by g into 100. Delta g by g into 100 is equal to delta r minus r. So upon r minus r. So what we have done here, we have assumed this r minus r as the whole entity. We have assumed r minus r as the whole entity. So error in this whole entity upon this whole entity plus 2 times delta t by t into 100. Okay, 2 times delta t by t into 100. Okay, so now what is going to be this delta r by r? Okay, now see, let's see in the question. So in the question guys, we are given that the values of r and r are 60 plus minus 1 and 10 plus minus 1. Okay, now they both are subtracted. So what is going to be delta r minus r? What is going to be, guys, delta r minus r? So see, whenever two quantities are subtracted, even then their errors are added. So this is going to be 2 mm. This is something we have learned. Whenever two quantities having some individual errors, if they are added or if they are subtracted, their maximum errors are always added. Whether they are subtracted or whether they are added, their maximum individual maximum errors are always added. So basically delta r minus r is going to become 2. Okay. And what is r minus r? This is 60 minus 10. We are subtracting just the true values into 100. And this is going to become 2 into, so this delta t by t into 100 we already have calculated 3.57%. So this is getting somewhere near 11%. So what is the delta g by g into 100 is becoming? It is becoming 11%. So this is also correct. This is also correct. So guys, this is a very tricky, very important, and so much concept. Almost every concept that we have learned in the error analysis, all those concepts were used in this very question. So this is how the questions are asked. This is how you can, you know, garnish your concepts. Okay. So guys, I'll keep it to this point in this session. In this session, we have done some very powerful questions of error analysis, and in this very session, we have understood almost all the concepts. We have applied almost all the concepts of error analysis that we have learned till this session. Okay. So guys, that will be all for today's session. Thank you very much. Don't forget to subscribe the channel, your very own channel, NEET Success Simplified, and hope to see you in the next session too.